So with that, I would like to introduce Dr. Nagyvary, who is our esteemed speaker tonight. He majored in chemistry at the University of Budapest and received his PhD in organic chemistry from the University of Zurich. After only 1 year in Cambridge as a postdoc with Lord Todd, he arrived in the United States in 1964, and his employment was at Yukon Stores as a research scientist. Dr. Nagyvary held other university positions, and in 1968, he began his Texas A&M career as an associate professor of biochemistry and biophysics. With a successful program in nucleotide chemistry, he became a tenured professor in 1973, a position from which he retired in 2003. All during that time, pursuing his passion for understanding the ethereal acoustic properties of world-class violins of the 18th century. So now I will turn it over to Dr. Joseph Nagyvary for his excellent presentation. Thank you for joining us.
Well, thank you, Jessica, for giving me the credit in advance. It's a great pleasure for me to be visiting with you again. As Bill Cesario remembers, I was here once in the late 1980s, and I'm still lecturing on the same topic, the mysteries of the old Italian violin. It is the physicists who have been always fascinated primarily by the violin, beginning with the very first great physicist, Galileo himself played the violin, and of course Albert Einstein spent more time playing violin in his old age than doing physics. Chemists not so much, although there were quite a few chemists more recently who became interested in the violin. I got captivated by the topic in 1957 when it was my good fortune to have access to Albert Einstein's violin, which was in my custody for 1 year. I like to show this picture primarily for the simple reason of vanity. I looked much better then. I sound just as bad now as I sounded in 1957, unfortunately. So I gave you a few more visuals. This is the only Stradivarius violin which is in mint condition. It has never been played professionally, and it looks like, and it could have looked when the master finished it. Stradivarius, you may know, lived to be 93, and during his long period of creative activity, he made something like 1,200 string instruments, of which there are still 650 or so extant. Most of them don't look like this. The typical Stradivarius violin has lost a good part of its varnish. There are chips on it, but some people actually prefer this kind of aged look. The reason why Stradivarius is admired by all violin makers is his impeccable workmanship. And this slide here shows very clearly one of the most difficult things for a maker is to make the edges with the so-called B string so perfectly. Stradivarius' workmanship was such that there was simply nothing to be criticized. And that definitely helped him in selling his violins at a high price. Here you also see the scroll of the Stradivarius violins, very perfectly executed. The other famous maker whose prices rival Stradivarius now was Guarneri del Gesù. And Del Gesù was a neighbor and contemporary of Stradivari, although he lived to be only 44 years old, and he made only 120 violins. His violins were quickly executed, and they are not very attractive visually. On the other hand, they have a very interesting, darker sound. Some people describe the Guarneri sound more like a dramatic soprano who is capable of singing low notes and very high notes, while Stradivari is more of a lyrical soprano. Now, the inside of the Stradivari depends on the condition you find it. If the violin was played very much by virtuoso players, this is shocking to see how much repair is on the interior of the violin. The entire center has been replaced, and I haven't counted, but we have something like 30, between 30 or 40 patches. Some of them are crack repairs, but many of them are for acoustical purposes to make the plate stronger. There are quite a few violins, though, which are in good condition, and they are shown here, 3 of them shown here. This is a CT scan of the first 2 are by Stradivari. They have nicknames: the Tiziano on the left, the Willemot in the middle, and on the right is a Guarneri, the Plauden Guarneri. So these are the violins where you don't have a crack, but there is a patch in the middle where the sound boost and the bridge is, just to make sure that the sound boost pressure and the bridge pressure would not cause a crack on the violin. So after these visuals, I don't know if you see the title of my slide. Actually, I don't see it. The Stradivari Paradox is my title here, which one of the magazines called the greatest puzzle, one of the greatest puzzles in the universe, which is probably a slight exaggeration. The paradox is that the violins were made 300 years ago, and their excellence could not be reached even in the 20th century by much more modern technologies, by highly educated people. So this is the million-dollar question. What is behind the excellence of the Stradivari violin? And when we talk about excellence, I mean both the visual, artistic impressions and the sound, which would not be reproduced. The dealers and writers tell you he was a singular genius, and his inspirations were out of this world, which sounds very nice if you want to sell the violins for millions of dollars. And the Stradivarius now fetch something up to 20 million a piece. Very dramatic increase in the last 20 years. The physicists have been always argued that there are simple physical reasons behind the sound, and they can be elucidated by diligent work, and they have been at it diligently for the past 200 years, and they still plan to work for quite a few years on the physics of the violin. There are still many things to be elucidated. I am one of the people who actually is championing the chemical material paradigm of the violin. We think that the ancient secret recipe hypothesis has some merits. People have thought for a long time that maybe the wood was treated by certain secret juices, or maybe the varnish contained something of interest. So here I want to give credit to the first chemists who actually spent some time on analyzing, doing chemical analysis on violins. The first one to be mentioned is Joseph Michelman, who published a couple of papers in 1946. He was fortunate to be able to analyze some of the ashes of a Stradivarius violin from Germany, which was burnt during World War II. And he found many interesting minerals which normally you don't find in the wood itself. Among others, which caught my attention, that he found boron in the ashes. The other chemist was more recent, Louis Condax, who worked for Eastman Kodak, and he did some analysis of the varnish and the layers under the varnish. And he was the first who found amino acids on top of the wood. And he was the first to suggest that the Italian makers covered the wood with a protein layer, a very important part. So for those who really don't care much about violins and don't know much about violins, I wanted to show this drawing of Colin Hutchins, who was one of the most distinguished researchers of the violin. So the geometry of Stradivari and Guarneri violins is well known, and makers try to reproduce them exactly, and the sound is different. Actually, there is one thing they have not reproduced, which is very important though. The center of the Stradivari violins, where the bridge is, and the circle around it, is very thin. It's only 2 millimeters thin in most of them. The modern makers have to make it much stronger, generally 3 millimeters, which is a huge difference from 2 millimeters to 3. And also another important difference, the weight of the top in the Stradivari is generally under 60 grams. The modern violins are 70 grams or more. The modern makers have to make it stronger because otherwise the belly top would cave in under the pressure. So here clearly we can find a very important deviation, a very important fact that we have to consider. Stradivari must have used a very special process to make the belly, the spruce, stiffer than what the modern makers can do. Well, let's go through the process, how the violin maker actually begins making the violin. For the past 100 years, the logs are taken from the mountains, from the same mountains used by Stradivari, the Val di Fiemme region in northern Italy, and they are transported down by the trucks. 300 years ago, they were sent down by the river route, and I'm not sure now because I forgot, but I believe this slide comes from Szeged, from my hometown, where the logs came down from Transylvania on the river Maros. And we can assume that the Adige River and other rivers delivered wood to Stradivarius' workshop. If you want to really figure out learn more about the wood, all we have to do is to get wood chips from all these instruments and analyze them. Now, this is very easy to say, but I have been trying to get those wood chips for the past 40 years. And during 40 years, I could get only 3 wood chips. So you can imagine that when you approach Itzhak Perlman with a scalpel in your hand, or Joshua Bell asking for a little chip from here, from there, the reception won't be very friendly. And this is one of the problems why we have such a difficulty publishing these results. We have a manuscript together with my colleague from Taiwan, H.C. Tai, which has been kicked around now more than a year, because reviewers always suggest that why don't you take 15 more samples to get a better statistical significance? Well, that might take another 50 years to get those things. So in any case, that's what the shavings look like that we went on to analyze. The first EDX, energy dispersive X-ray fluorescence analysis of ashes from Cremona violins was made at Texas A&M University by me and my colleagues there in the Electron Microscopy Institute. And these were published in Violin Society journals, which that time were not peer-reviewed. So this already shows that there was a lot of calcium in that particular cello by Stradivari. Later on, we also analyzed for boron, and we found that the Stradivari violin and the Guarneri del Gesù violin had significant amounts of boric acid in them, while the French and the English instruments had only traces. Now, since boric acid and borax is known to cross-link carbohydrates, one could hypothesize that this could have had beneficial effect on the sound. Very recent work, quite a few people analyzed wood, minerals, but only qualitatively. The only quantitative analysis was done by a team led by above-mentioned H.C. Bruce Tai, a professor, young professor at the Taiwan National University. And this, the paper has something like 20 co-authors. I'm one of them. And we hope that now, finally, the paper will be accepted in spite of having only 6 specimens for analysis. And here is a summary of the result, the difference between Stradivari instruments and Guarneri del Gesù instruments. In the Stradivari ash, the ICP is inductively coupled plasma mass spec. I don't know if there are analytical chemists among you, they would know this method of analysis. So these data are parts per million. Here I calculated in percentage. The Stradivari wood has a very high amount of sodium, most likely in the chloride form, because the chloride is also high, good amount of potassium, significant amount of calcium, and a relatively small amount of aluminum. The Guarneri del Gesù, in contrast, has very little extra sodium, some, but not very significant. It has much more calcium than the Stradivari, and it has also more aluminum than the Stradivari. What's important here to note that the total amount of salt which goes into the top plate of these instruments, which average from 60 to 66 grams, the Guarneris are somewhat heavier, is something like 0.6 to 1.3 gram. This is a very significant amount of minerals which one can surmise that they have consequences for the sound. So here I am showing a carbon-13 mass spectrum, not mass spectrum, NMR spectrum of the wood, finely chopped wood. And this was done by Joseph Di Verdi at Colorado State University. So here you see on the bottom line is the untreated maple. I show boiled maple, boiled and baked maple. The baking was at 100 degrees. The Guarneri misspelled and the Stradivari. The part of the spectrum which is easy to see. Here to the right is Little Peak, and to the left, the two utmost side peaks. These come from the hemicellulose part of the maple, hemicellulose acetyl groups. And as you boil and so on, this goes down. In the Guarneri, it's very low. A significant amount of the hemicellulose acetyl group is lost, and possibly the hemicellulose itself is partially hydrolyzed. So the Guarneri shows the greatest change. The Stradivari, at least in this cello, is more intact. I also show something which hasn't been published before. I collaborated with an old friend from my Cambridge year. Dr. Noel Owen was for a long time a professor at BYU, a specialist for wood infrared. And this Fourier transform infrared was taken on a German commercial maple sample. And to the right, these are the cellulose, hemicellulose, lignin peaks. And to the left, there is a significant amount of water peak. The commercial maple contains something like at least 14% water. Here is the Stradivari maple. If you just, this is not very quantitative, Dr. Owen pointed out, but still indicative of the fact that the water relative to the other organic part of the wood is much lower. There is much less water in the Stradivari wood than in the wood of most other makers. This can have many reasons. Age is one of the reasons. The best violins are nowadays made from wood which is very old. Now, why is the wood of Stradivari so low in water? Of course, we don't know, but I have an attractive hypothesis which really fascinated me for many years. This is the house Stradivari lived in. He was a rich man. He had a nice 3-story house. And on top of the house, that's where he worked. And on the side that you don't see, there was a chimney there. And in this chimney, they normally smoked sausages. I like to imagine that Stradivari also put his violin wood into that smoking area, which was then heated, the water chased out, and replaced by various smoke chemicals. Just one hypothesis. So I think this brings me to the end of the wood story. The chemical changes in the wood cause a decrease in moisture content. And when you decrease the moisture content, you increase the stiffness, the Young's modulus. And this allowed Stradivari to make very thin bellies for his violin. The other part of the violin is, of course, the varnish, the outer look of the varnish. And this shows a cross-section of the best preserved Stradivari varnish, which I was privileged to lift out myself in 1984. And this is from a cello. The cello belonged to a friend in Austin who passed away since, and then he sold the cello to a collection in Taiwan now. This is visually such an attractive picture. Actually, it reminds me of some of the pictures taken by the Hubble telescope, like, stars are forming, galaxies, and so on. There are 12 layers here of different colors. The stratigraphy is just absolutely amazing. Nothing which was done after Stradivari even remotely compares to this. I use this picture as a decoration in our house. Now, by the way, this work was done on my sample by people at Macron Associates in Chicago. Robert Mugley did the excellent work. So he came up with these 12 layers. The total thickness of the varnish on the cello is rather thick, 90 micrometers. We have clear varnish with particles in it. Then we have light brown varnish with iron oxide, quartz, and carbonates. We have dark brown varnish with few particles. Then colorless layers, iron oxide, red and brown iron oxide, colorless layer. We have carbon black, another light brown layer, colorless layer, calcium carbonate, large concentration. Absolutely fantastic. His neighbor, Francesco Ruggeri, he also had a complex varnish on his cello, but it was thinner. He also had his color separated by colorless, and the color came mainly from iron oxide. Although there were organic pigments in them, we did not analyze for organic pigments. Such analysis was done later by others, primarily in France by Eschard, whose name I will give later in the literature. We have shown by SEM microscopy at Texas A&M that many of the old varnishes on their underneath at the wood surface had very dense microcomposite, and specifically Stradivari also had even finer particles which fall now in the realm of nanocomposites. It's amazing that people 300 years ago were able to make anything like this, a nanocomposite. So this is what you find in cellos. I had no luck trying to get samples from violins. The violin varnishes of Stradivari could be analyzed only by the people who worked at the museums who owned these instruments. The Musée de Musique in Paris was a place where the French researchers actually could analyze. The German banks and the Austrian banks had some Stradivari violins, and they allowed the analysis of the varnishes. So there is a big book published by Brandmeier and Greiner entitled Stradivari Varnish, and they have many pictures of varnish cross sections on violins, which are much simpler and much thinner than the cello varnish. From point of view of acoustics, it makes sense that a violin varnish should be thinner than the cello varnish because of the frequencies involved. They came up with this general scheme, also from the same publications, which, by the way, is a 10-pound heavy book that you can buy for $800. So instead of wasting their time going to scientific journals and dealing with the unpleasant task of quarreling with reviewers, they made the wiser deal. They are selling it for money. And no one argues. You can buy it. Probably it's out of print. Probably you would have to pay more than $700. So the general conclusion is that all the Cremona makers first put a protein casein layer on the wood, and there would be gypsum in the casein, which comes from the milk. And on top of that, they had the colorless or just pale, brownish, pale, yellowish, golden brown varnish layer, which again had particles in it. The casein prevented the organic to penetrate deep, and that's important. And on top of this thin layer comes the colored layer, which itself may have some color, but mainly it is loaded with very small size pigments, organic pigments, like carminic acid from the cochineal insect, or the madder root pigment, which is a glycoside of the alizarin dye. These were the main red colors, and there were a number of other yellowish colors. So I think that much about the varnish. If you want to make a great violin, of course, I have to, point out that you also have to be familiar with major breakthroughs in the physical acoustical research of the last 50 years. They introduced methods to describe the sound of the violin in terms of frequency response curves. They developed finite element analysis. These are engineering methods that they applied to the violin. Modal analysis. We know now how the violin bends, where the nodal lines and anti-nodal lines are when you play each note on the violin, and that's an important part. They apply CT scans, laser optical testing, phonetic analysis for vowels in the violin notes. When you play a violin note, sometimes you can actually hear certain vowels. So if you do all that, actually, you can create a better violin. And this is just an example of the frequency response curve of Stradivari and Guarneri violins. This slide I show, here is the violin analyzed by CT. And next to the doctor is the most famous violin maker of our time, Sam Zygmuntowicz, whose violins many people say are really comparable both in sound and looks. His violins sell now over $100,000, and he's particularly close to my heart because when he was a student, his first violin he made for me, for my studies, out of my wood, which I soaked. He didn't know that, but I soaked actually. I must admit, I should admit, I collected urine in the men's room for soaking the violin to soften up the wood. The violin sounded fantastic. I paid $500 for it. And Sam is a great believer in chemical treatments of the wood, by the way. So here I have a summary, my explanation of the Stradivari phenomenon. The acoustic, you can read it off, of course, the acoustical excellence owes a lot to chemical preservatives. And Stradivari possibly could have been aided by the owner of the drugstore, who happened to be his neighbor. Stradivari produced 1,200 instruments, much more than his competitors, and the more labels you have around, of course, that helps establishing a reputation. He selected the best wood. Stradivari wood density is extremely low. Most of the wood I am getting is barely under 0.4. His workmanship was exceptional, and if you want to sell a violin, of course, the looks is the most important. Many people don't realize, but Stradivari invented a new business model. He did not sell any violin to a musician. He sold violins only to kings, popes, bishops, and English bankers, only to the super rich who protected the violin, and their reputation added to the value of the violin. It was much later than that violin virtuosos could afford actually to buy Stradivari violins. Of course, there are alternative facts, just like in politics. Many Stradivaris really don't sound that great because they were worn down by too much playing. And who repairs them is, of course, very important. Restorers a significant role. There is a well-publicized experiment by Joseph Curtin and Claudia Fritz with blindfolded players, and they found that the modern violins actually sounded better than the Stradivari violins. But this experiment, in my opinion, is not very telling because they did not identify the Stradivari instruments. It's not fair to compare the best modern violin with the average Stradivari violins. Here I have some recommended literature. The most important is the papers by Bruce Tye, published in the Violin Society of America journal. Here I mention Brandmeier and S.P. Greiner, Stradivari Varnish. This is the self-published book, 10 pounds in weight. I have 2 review articles from 2014, also in the Violin Society peer-reviewed journal. The most famous, most important French researcher is J.P. Echard from Paris. And if you get any of these papers, they have 50 references to everything before. The most important research in the recent years is done actually in Italy. Finally, Italians developed some sense of national pride and began doing analysis on violins with very modern methods. Synchrotron radiation microcomputer tomography is an excellent method which does not require removing parts of the violin. So you find many useful data under the name of Fiocco. Here I show Zygmuntovit's violin that was auctioned for 125,000. And I like to show my great supporter, Lord Yehudi Menuhin, who actually thought that my violin 1985 was the best modern violin that he ever tried. Finally, I should give acknowledgement to my mentor in physics, the late Professor Robert Kennefic. The Macron Institute associate was Dr. Mogli, Texas A&M, Dr. Ehrman, Guillemet, and then the infrared was Van Owen and NMR Diverdi. I had very little support, unfortunately. Violin business does not support research. I got a grant for a year from the Texas Board of Higher Education, the SCAX Foundation a little bit. And it sounds facetious, but my main supporter was my long-suffering wife, Marianne Nagyvary, whose grocery fund was usurped every year for various expenses related to the violin research. So I think I have spoken already too long. Thank you for the invitation. This was my first rodeo. If you didn't like it, I must say that I'm not exactly a practice Zoom performer. Thank you for your interest, and thank you, Bill Cesario, for discovering that I'm still alive.
Thank you so much. Everyone, you can feel free to either clap at the reactions you can find at the bottom of your screen, or else send your thanks and praise in chat. We'll now move on to the Q&A portion. Once the motorcycles decide to stop going across my street. And if you have any questions, feel free to post those in the chat. We already have a few that have been posted, so I will start with those. So Andrew, do you want to read yours or should I? We'll do it this way. If you don't respond within 5 seconds, I'll just read your question. So Andrew says, thank you for an interesting talk. In regards to the wood that Stradivarius used, I had heard it may have been reclaimed wood oars of boats that traveled the Mediterranean Ocean. Could this explain the level of salts found in the wood?
Yes, this is one possibility. Several people thought and did the suggestion. There are, of course, many who think that the wood was personally picked by Stradivari in the mountains, and then he put the wood himself in a salt solution. It's very hard to disprove or prove, but this is clearly a possibility. Yes.
Thank you. All right, next one is, did Stradivari have a workshop with apprentices or other workers? Did any of them become famous makers?
The general consensus is that unlike his master Amati, Stradivari probably worked with few apprentices. The reason being because he had two sons. And the two sons probably were enough. And I also suspect that he was not highly motivated educating others, creating a competition by disclosing his method to others. So that there is no famous maker who worked with Stradivari, really.
All right, Martha, would you like to read your question? All right. As someone who enjoyed the red violin, I just have to ask this. Has anyone ever found evidence of hemoglobin in the varnish of the violin?
No.
Or of a violin?
No, and as you know, probably, Jessica, hemoglobin turns brown. The red violin was red not because of hemoglobin, but when that thing came out, I went to the chicken plant in Bryan, Texas, where I collected chicken blood. And the chicken blood is actually more interesting than human blood because it has the nuclei, it has nuclei with DNA in it that would make it much stronger than human blood, which has no DNA, a large concentration of DNA. The varnish turned very ugly brown, so I discontinued that line of research.
Did I have to ask a follow-up, which is, was that one of the examples of the grocery fund going to buy a chicken?
No, actually the expenses were more significant than just buying the lots of chicken. You know, I mean, I had to travel to Bolzano and buy, you know, wood there and, you know, and pay for travels to get chips, chips of Stradivarius wood and varnish, yes.
Wow. All right.
And instrumentation, you know, I mean, it's expensive just to buy microphones for $1,200, you know, preamps for $600. It adds up.
Absolutely. Jason, do you want to read your question?
Unmute.
There we go. Hello. Hi. First of all, thank you for speaking tonight. It's been a lot of interesting information, honestly. Question I have for you. Do you know if any of these chemical finds could be found in other related instruments? For example, viols, bassy, like other string instrument related families. I know you mentioned cellos earlier.
Yeah,
but
I believe that the French researchers analyzed some other stringed instrument, which is not a conventional instrument, but some ethnic instrument of some kind, which is old. But I'm not sure now whether it was a Dutch or a Norwegian, what kind of instrument. I honestly have not followed that kind of work because simply life is too short. And I was preoccupied really with the famous Italian makers.
Sure, understandable.
All right, question from Dennis, if you'd like to ask it.
A related question related to the other instruments. New York has had a very famous oboe maker. I don't know if you've ever heard of Paul Laubin. He recently passed away, but he had made 2,600 oboes largely by hand. And I wonder if any of his instruments ever found their way into the literature.
No, I mean, I love the sound of the oboe, and I know, you know, some of the oboists in orchestras, and I know that they were really preoccupied with the reed that they put into the instrument, but I am not aware of any analysis, any of the particular details of how the oboe is actually made. Again, you know, that would require a special interest, and you have to specialize nowadays on something. So I am just with the instruments which are bowed, string instruments that are bowed. I did not even spend time on guitars, although Stradivari made a few guitars. But I don't think that the Stradivari guitars are any better than any other guitars. So that was not again the focus of interest.
Thank you. I had one question, which was the hemicellulose peak that I think was around 175 ppm in your NMR.
Yes.
You showed that it goes down with boiling, but I was just wondering, like, what's the degradation lifetime in general of hemicellulose, and is it possible that the hemicellulose peaks in the Stradivari and I believe Ghana violins just degraded over time?
I did not show those data because they will be published by this manuscript that we have with Bruce Tai, the Taiwan author. And in that paper, there are NMR spectra of old wood, which is 200, 400 up to 800 years old. There are, he analyzed wood from very ancient Chinese musical instruments. And that shows that age makes definitely a difference. There is less water in it, there's less hemicellulose in it. But considering the age of the Stradivari violin and the Guarneri violins, just the wood at that age, there would be more intact hemicellulose than the Stradivari violin. He also thinks that the vibrations alone actually could be a contributing factor. So it's not the same if you have a sample from a construction wood from a building or from a violin, which is then constantly vibrated. That is clearly something to be considered. One important thing is to emphasize that you cannot make a great violin for new wood. Anyone at a competition who wins an award on a violin for sound, the wood must be at least 100 years old.
Wow. I guess a follow-up question to that is, with a lot of metals, we tend to find that, if you want to do lab grade metal, you have to take metal from the reclaimed ships from before the first nuclear bombs were dropped. Has there been any difference between the wood that was perhaps constructed before the nuclear bombs were dropped and after, in a similar fashion?
Well, I don't know about the nuclear bomb effect, but the climate seems to have an effect on the wood quality. And Stradivari lived at the time of the minor ice age. And there is a hypothesis. Some people think that in the same area for about 50 or 80 years, the growth was slower, and that could have had an effect on the structure of the wood, the stiffness of the wood. Maybe, but this is certainly not enough, because the same wood was available to the Austrian and the Czech makers, and they really did not make great violins. So there was something special about those violins made in Cremona.
Thank you. We'll take one final question, which is from Olivier. Do you want to read it?
Oh, you can read it. That's okay.
All right. Can we tell that nowadays some violins are made just as good as those of Stradivarius?
Yeah, I mean, many people think that by now, violin makers who are very astute, they follow the scientific discoveries in this regard. The best violin makers are engineers. They studied physics. They really know how the violin works. And if they use the proper wood, if they use the right chemicals, the violins come very close to a good Stradivari violin. But there is one aspect which is missing, the playability. The violin has to be played a certain number, a certain 1,000 hours of playing to develop the easy playability. So to the listener, the best violins may be as good as a good Stradivari violin, but for the very distinguished players, the caliber of Joshua Bell or Anna Sophie Mutter, the playability is different. It just does not play as fast and doesn't speak as easy as the Stradivari violins. Now, no modern violin comes close to the top 10 or top 20 Stradivari violins. The comparisons are made with the Stradivari violin ranked number 200 out of 600. So, you know, that's a far cry, really. These comparisons are hard to make because you don't get the best violin, the owners of the best violin, they don't lower themselves to a comparison with a violin with a modern maker. That's how it is.
All right, with that, let's all thank Dr. Nagyvary one more time. If you want to find out more about the ACS New Haven section or about the ACS in general, please email me at jessica.freeze@yale.edu. You can find that email also in the emails related to this talk. If you enjoyed this talk and you would like to listen to it again, it will be posted on our YouTube channel, ACS New Haven. In about a week's time, I will be sending out the link to all of you. Thank you for attending, and I hope you have a wonderful evening.
Thank you.
Yeah, thank you.
Thank you. Thank you.
I guess I just have to find now how to check out. Okay.
All right. I will end the meeting for everyone. Have a wonderful night.
You too.
Dr. Nagyvary.